Hello everyone. I wanted to talk about the connection of design and engineering with an example. So let's say you were asked to design a shoe for bicycling, a Brazilian shoe for a serious road bicyclist in Brazil. So let's say Senhora Teotihuacan calls you up and says, hey team, let's come up with some good ideas for a Brazilian bicycle shoe. And so you gather your group together and you come up with all these sketches and you pursue a wide-ranging, free-flowing, unfettered association of ideas, and you look at complex things and beautiful things and practical things, and then you get that out of your system. That initial ideation, you get that out of your system. And then you move into scoping the thing out a bit. So you move more into professional design, which is sort of some questions that seem boring at first, but it's sort of, what's the regulatory environment? What laws might govern these things, either Brazilian laws or bicycle association laws. And you might look at other countries that are part of this market that might be important. So what does Brazilian mean? Does it mean also Peruvian and Chilean and Argentine and Colombian and Guyana and Venezuela and so on and so forth? Is that part of the equation? Is the export market big? What's that like? And then you ask, how many are we talking about in terms of sales volume? What's our price point? So these are kind of scoping in issues. And then you move into design research, which you're good with. So you're looking at sort of user data, you're acquiring user data, and you're determining what the market might most want. And you might use design tools like experience maps for identifying pain points. You're going through all that process of on the design side of creating an appropriate product. And then you are also maybe looking at brand management, these sort of things. But then let's say Senhora Teotihuacan brings in her boss, Senhor Caracari. And he doesn't like Senhora Teotihuacan. Okay, it's an incident that happened in Boa Vista that nobody talks about. But anyway, there's some sort of angst between them. And he looks at you and he says, okay, napkin sketching lightweights, what's the deal here? What's going on with this design? Because you have this design, you bring it forward. And you say, here's our idea. And there's a bunch of ideas, and they're wonderful ideas. And you say, well, when we looked at this, we thought about, who the user was and what the issues were that we should be concerned with. But then we thought, these are serious bicyclists, and they want shoes that perform really well, so they have to fit well. And I start looking at anthropometric data and looking at ergonomic issues, of which many you have to throw under the bus because trying to keep a shoe in neutral position and these sorts of issues are hard to arrive at in the case of the shoe. And then you say, well, but then we looked at these engineering issues and we think, well, heat's a big problem. Bicyclists generate a lot of heat, and we know that skin that doesn't grow hair is a great way to dissipate or gain heat. So the soles of the feet are a ripe surface for us to tap into. So we created this kind of high thermal conductivity sole with these convective channels that run under the sole. And we asked ourselves, well, what are the rheological properties of there? How does it behave at these speeds and at bicycling speeds? And we put in turbulators at the inlet of these convective channels to trip that boundary layer from laminar to turbulent more quickly to improve the convective heat transfer. And then we changed the actual form of the shoe. We put this closing section that's a little more aerodynamic to reduce the pressure drag. And we think the lacing structure will incite the turbulent boundary layer, so we'll get lower pressure drag across these shoes. And we think these aerodynamic pieces that we add, they're subtle, they have a purpose, both in terms of reducing drag, and they have a distinctive look. We think that techno look will be appealing. And then Mr. Caracari or Senhora Caracari says to you, well, can you expand on this a bit later? And then you respond, Senhora Caracari me não fala Portuguese, because he's talking in Portuguese, and you don't speak Portuguese. So you've diminished further down on his radar as a napkin sketching designer. And he says, well, can you expand on this further? And he said, well, we know these principles connected with drag that we're concerned about. And we think that the combination of these aerodynamic features and these aesthetic features will work synergistically to give your users what they want. And we've looked at high emissivity coatings on the shoes. We've looked at fatigue points because we're concerned about that. pressure points internally. We've tried to systematically address all these actual functional issues, and we're ready to do some computational fluid dynamic modeling on the shoe itself, and we're confident you will like this, Signor Karakari. And Signora Teotihuacan is very happy that you moved beyond describing, developing visual hierarchy through using complementary colors and such to, and the whole design and research, you've moved from that into, and fluidly, into the engineering realm. And you are a hero. So let's say something else happens. Maybe you're asked by Astrid of Sweden to design a fishing boat for small fishermen in South Sweden. And you look at this issue and you say, well, okay, there's a lot of technical things this fishing boat has to do. There's a lot of these mechanistic things to keep them safe and make them produce fish and use fuel efficiently, et cetera, et cetera. And you look at the visual hierarchies of, or you look at rather visual stereotypes of existing fishing boats, and you look at what they're used to, and you come up with these ideas, and you start kind of dissecting what's out there already, because your design research is suggesting that these Swedish fishermen do not want to change their designs with alacrity. They'll resist change. And you come up with some clever innovations. You think, well, let's look at stability. That's a big issue. And you look at things. Let's move the engine lower. We'll get a Z drive, like a sail drive, and we'll drop that really low in the boat because draft is not really an issue in these ports in Sweden. The water's very deep, so we can go deep. And we'll put a bulbous bow in there that retracts to reduce the wave-making drag. So we're going to lower the center of gravity. We're going to reduce the beam, the width of the boat, to improve its sea kindliness. We're going to do a lot of things below the water to make it more hydrodynamically efficient. We're going to open up the stern to make it more flexible as far as how it works. And then maybe Anna comes in from Norway. And she says, "Vi ska ikke ha den, det är dåligt." And Astrid says, "Oh, it's a Norwegian." And hon inte pratar engelsk, so she talks to you in English. She says, everything that comes out of Scandinavia has these unique components. A Dane has designed it. Us Swedes have made it. The Finns have built it. And the Norwegians criticize it. So be careful with Anna. So you talk to Anna through a translator, and you say, this boat will work better because we've opened up the stern, we've addressed all these mechanistic things, we've kind of looked at the tradition of these boat designs and kept the parts that the users really, really need, trust, and count on, and we've tweaked gently because our design research shows that they're really resistant to too much change to make things a bit better. But we've looked at, so we've addressed these non-mechanistic issues, but we've looked at the mechanistic very carefully. These boats are now more stable, lower drag, and better at doing fishing. They're going to save fuel, they're going to have longer range, and they're going to work better. And Anna is finally happy, and there's great peace in all Scandinavia from your fishing boat design. And these are just some fun examples of sort of blending design and engineering. Being able to work fluidly between those disciplines is really helpful and makes you a real powerful force in the world of innovation. Thank you.